Welcome back to Math 107 College Algebra. In this video, we're going to take a look at how to find the asymptotes of rational functions. So we're going to use a rational function x squared plus 4x plus 3 over x minus 2. So the first thing we want to look at is vertical asymptotes. Vertical asymptotes are going to occur where the denominator is 0. So we simply set the denominator equal to 0 and solve it. We get that x equals 2 is a vertical asymptote. Now to find non-vertical asymptotes, we're going to go ahead and do the division on this. I'm going to go ahead and use synthetic division here. So I bring down the 1, multiply by 2, and add. Multiply by 2, and add. And one of the ways that I can write this is to say that our function here, so I didn't explicitly write that as a function, is equal to x plus 6 plus 15 over x minus 2. So I just write the remainder as a fraction, similar to what you did with mixed numbers back when you were in elementary school. But now we start thinking, what's going to happen as x gets really big? And we'll start to notice that if x gets really big, that remainder fraction at the end is going to get really small. So the function is going to get really close to that x plus 6. So we can say that y equals x plus 6 is an asymptote of the function. Now, a result of this is you're only going to have one non-vertical asymptote. Could be a horizontal line. That's going to happen if the degree of the numerator and degree of the denominator is equal. In this case, degree of the numerator is greater than the degree of the denominator, so we got a asymptote that wasn't horizontal. In this case, it's a diagonal line, but it could be a quadratic, a cubic, or something like that. Now, one of the things we can do when we have the same degree, so I could do this the normal way. So I'll use synthetic division. So I bring down the 1, multiply by 2, and add. And I end up getting, we'll call this g of x. So g of x equals 1 plus 6 over x minus 2. So I did it that way. I just as easily, when it's something like this, could have taken the leading coefficients, which are understood to be 1, and there's nothing there, and just divide them. So I can only do that when the degree of the numerator and degree of the denominator are the same. But I can always just do the division and take the quotient as my asymptote. So we'll take a little bit deeper of a look into this in class on Thursday. I will see you then.